So we just started a quick revision series of atomic structure chapters. So today we are going with electronic distribution. So we have so many three main principles or rules which we need to follow while dividing electron or electronic distribution. So distribution of electron in shells, subshells, orbitals of an atom. Of course we'll do according to shells, subshells, electrons, orbitals, and they have definite rules. This means we need to follow rules in order to distribute electron and orbitals of subshells in an atom. So first one is Aufbau's principle. So this principle, you usually would have seen that we do have a lot of principles are on the scientist name, but this is the one principle which is not followed or not on scientist name or something. No scientist name. Okay, so this alpha is a German word, by the way. This German word which means building up, means building up. Okay, so this is building up, and this one what was said, this this is the modification of Pauli's exclusion principle. So I think before we go with Aufbau's principle, we need to know about Pauli's exclusion. So this is two electrons in the same orbital must have opposite spin. So yes, they said that the spin could not be same. If I just make a two electrons, they have the same set of quantum number, but they need to be different spin. How? Because in spin we have plus 1 upon 2 and minus 1 upon 2. So it's like whether you are taking 6 number, 3 number, so you need to make sure that the spin is different. Like in sometimes it will be plus 1 upon 2, sometimes it will be minus 1 upon 2. So that type of, so this mean they need to be have different spins just because of this reason. So even if I just make a flowchart, it would be number of electrons. If I just take 1, so in L shell it would be 0, in M shell it would be 0. In spin we need to make sure that it's like 1 upon 2 or minus 1 upon 2. Okay, so this means we need to make sure this one. So Pauli's exclusion was only about two electrons, they are in the same orbital, but they cannot have same spin. This means they're opposite, they must have opposite spin. This was about Pauli's exclusion principle. So I'm sure it's clear. Then if we come to Aufbau's principle, this is not on scientist name, whereas this is on German word which is building up. And what else it tells? It tells that if we give division, if we distribute electron, first we need to make sure that we are dividing electrons which has the lower energy. So it's like the first rule was lower energy would be assigned first electron. Lower energy, the first electron would be assigned. So first occupy lower energy orbital, and also increasing order of energy of orbitals or shells. Now let's, I know this is so mess looking here. Well, so what does it's written, the electron should be filled in energy and subshells in order of increasing energy rules. So this means first, if I'm giving, for suppose we have energy of 2, 4, 6, so first this would be filled. This means this have the low energy. First we need to make sure we are filling this, then this one, then this one. So it's in order of increasing energy levels. So this means we need to start from lowest. The electrons are first placed in, like, these are the number of configuration type or of path principle tool. So I'm just making you understand this one. It's like 1s, 2s, 2p, 3s, 3p, 4s. It's like we have orbitals as we discussed last year as p, d and f. So it's like first would be s, and in 1s, 2s, only in s we will have these two. In p we have this one. Then like 1s would be taken 2s, 2p. In the third we have 3s, 3p, 4s. And this one we have 3d, 4p, 5s. Here we have 4d, 5p, 6s, 4d. It's like a number of, and this would be continued. So you need to make sure it's like s would be taken first, then it will go with p, then it would be go on with d, then it would go on with f. Okay, oh sorry. So I'm sure it's clear to you. Then we have another rule which is Hund's rule. So what exactly was told in this rule? It's very easy. I'm just making a chart before we start. Oh yes, we do have chart here, but these are of electron elements. We are starting with basic S, P, D, F. So it's this Hund's law says that electrons or the energy would be given equally. So in this Hund's law, it's like orbitals of same subshell, they possess energy, and that's called as degenerated orbitals, because here it's written degenerated orbitals here. So you need to know what these are orbitals of same subshells, they possess same energy, they are called as degenerated orbitals. Okay, so I'm just telling you, like, we have S, P, D, F. So in S, it's like we need to make sure if this is the box, one would be clockwise, second would be anti-clockwise. Then we have P, here we will have three numbers like 1, 2, 3. So we need to make sure we look into clockwise, anti-clockwise too. So one here it will be first like this, second opposite, first like this, second opposite, first like this and second like this. So this means here are the 2, here are the 6, and in this one we will have 10, because 2 2 2, like we make 5 boxes, 2 3 5. It's like this one, of course not the same, different uh, sides, and then this one will have 14. So it's like 2 6 10 14. We'll have opposite, and this 2 like this, for more than like 7, for the 7 times, 1 2 3 4 5 6 7. So this is electronic configuration. Now let's read this one. Here it's written, if degenerate orbitals available and more than one electrons are to be placed in them, they should be placed in separate. We need to make sure that we are placing these all electrons in different places. They should be separated orbitals with same spin rather than putting them in same orbital. So it's like we cannot do like, if this is the one, we can do like this, or we can add more than 4, more than 2. That's not possible. We need to make another group like this one, and we need to put it there, but we cannot like add them together, right? So I'm sure it's clear. So this is all written in this Hund's law. Degenerate orbitals, they should be available. If they are available and they are like more electron, so we need to make sure we are making another box or giving them a separate place. So electron configuration for hydrogen, it's like 1, for helium's 2. So we'll make like 1s would be written, helium is also 1s2. So here the box would be like this one, 1 means like we don't need to, we'll look into this energy which is written 1s2. This means we need to make one box, because 2 can be in one box like this. Then we have few others. We have lithium has like 1 plus 2, this means 3. So 3 would be placed like this, first 1 1 2. This means we need to make one box where 1 would be added, right? Then we have again beryllium, so this is 4, 1 and 2. Here we'll also do like 1 2. Then we have boron, so boron has like around 5 if I'm not wrong. Yes, 1 2 3 4, it's like just 5, so we'll do like 1 2 3 4 and 5 would be, one more would be placed here. So it's like that. I'm not going with all, because I don't, because you can also do it. Well, carbon is also very important, so let's go with carbon. So 2 plus 2 4 1 1 1, this means we have 6. So how we'll do that? 6, one box with 2, one another box with 2, and for 6 it's like XYZ. Wherever you see XYZ, so just make sure you're making box in 3 1 2 3. So it's like 1 here, 1 here, and here would not be placed, because in this one you can see here it's 0. So 2 plus 2 plus 2, even you can see the number have been confirmed. So 6, so that's 6, right? So it's like you can go accordingly with all. I'm sure that's clear. So yes, these all were the rules. So thank you for watching. Bye bye.